The Consensus Wars by John Kitchen. Copyright 2025. All rights reserved. This is a work of hybrid fiction that was created in an iterative process using multimodal large language models. Any resemblance to any person, place, or institution, living or dead, is purely coincidental. Chapter 2. The Laboratory of Minds. 3 months after the symposium, Elena found herself standing in a converted warehouse in Oakland at 2 in the morning, staring at walls covered with social network diagrams, psychological profiles, and flowcharts that looked more like intelligence analysis than academic research. Coffee cups and energy drink cans littered tables laden with tablets, smartphones, and monitors displaying real-time data streams from social media platforms. "Welcome to the Meta Lab," Sarah said, emerging from behind a cluster of whiteboards covered in equations that mixed statistical formulas with what looked like cognitive behavioral therapy models. "We're studying the science of science acceptance." The space hummed with an energy Elena had never encountered in traditional laboratories. Urgent, transgressive, electric, with possibility. 7 other researchers moved between workstations with the focused intensity she recognized from her own climate modeling sessions. Except these scientists weren't tracking atmospheric data. They were tracking beliefs. Dr. Alex Petrov, a former MIT computer scientist who'd left academia after his artificial intelligence research was co-opted for surveillance technology, looked up from a 3-monitor setup displaying cascading network visualizations. "Elena, perfect timing. We're about to run the first real-time belief propagation model." Belief propagation? Elena moved closer to examine the screens. The visualizations showed thousands of connected nodes, some pulsing red, others blue, with pathways of connection lighting up like neural networks as information traveled between them. "Think of it like climate modeling," explained Dr. Maya Okafor, a former epidemiologist who'd pivoted from tracking disease outbreaks to tracking the spread of misinformation. "Instead of modeling how CO2 moves through the atmosphere, we're modeling how ideas move through social networks. Same mathematical principles, different substrate." Elena felt the familiar thrill of scientific discovery, but underneath it lurked something more complicated. "Are we studying people without their consent?" "Public posts on social media," Sarah said quickly. "All anonymized, all aggregated. We're not reading individuals' private thoughts. We're mapping how information flows through public networks. It's like studying bird migration patterns or ocean currents, except the patterns are made of beliefs instead of molecules." The comparison didn't entirely reassure Elena, but she found herself drawn to the screens anyway. The visualization was hypnotic, ideas spreading from node to node, some dying out quickly, others amplifying through the network like viral infections. "Show her the vaccine hesitancy cascade," said Dr. Rajesh Gupta, a former pharmaceutical researcher whose insider knowledge of clinical trials had proven invaluable for understanding how medical misinformation gained traction. Alex clicked through several screens, bringing up a time-lapse visualization from the previous month. This shows how a single anti-vaccine post by a parenting blogger in Phoenix spread through the network. "Watch." Elena watched as a single red dot, representing the original post, began triggering connections to other nodes. Within hours, The red had spread through clusters of connected users, jumping across geographical boundaries and demographic groups with frightening efficiency. 7 million people saw variations of that post within 48 hours, Maya noted. But here's the interesting part. Watch what happens when we introduced counter messaging. Blue dots began appearing on the network, representing fact-checking responses, medical professional statements, and official health organization posts. But instead of neutralizing the red dots, they seem to cluster in separate areas of the network, rarely intersecting with the misinformation pathways. They're not talking to each other, Elena realized. The facts and the misinformation are operating in completely separate ecosystems. Exactly, Sarah said. Traditional science communication assumes we're all part of the same information ecosystem, but we're not. We're operating in parallel universes that barely touch. Dr. Lisa Zhang, a former neuroscientist who'd left brain imaging to study the neuroscience of conviction, pulled up another visualization. This is where it gets really interesting. We've been analyzing the neural correlates of belief change using fMRI data from volunteers who agreed to have their brains scanned while consuming different types of scientific information. The brain scans showed patterns Elena recognized from atmospheric circulation models: areas of high and low activity, pressure systems of thought that resisted change like weather fronts. When people encounter information that confirms their existing beliefs, Lisa explained, we see activation in the brain's reward centers. It literally feels good to be right. But when they encounter contradictory information, we see activation in the same brain regions associated with physical pain. So, disagreeing with someone's worldview literally hurts them? Elena asked. From their brain's perspective, yes. That's why facts alone don't work. We're asking people to voluntarily experience pain in exchange for abstract accuracy. Most people aren't going to make that trade. Elena sank into an empty chair, processing the implications. As a climate scientist, she'd always believed that data would eventually speak for itself. The atmosphere didn't care about politics or feelings. Carbon dioxide trapped heat regardless of what people believed about it. But people weren't atmospheric molecules. They had emotions, identities, social connections that shaped how they processed information. So, what do we do? She asked. If facts cause pain and fiction feels good, how do we change anything? Sarah smiled, not the comfortable smile of someone with easy answers, but the complicated smile of someone who'd glimpsed a difficult truth. We get scientific about changing minds. We develop hypotheses about belief formation, design experiments to test them, and iterate based on results. That sounds like... Elena paused, recognizing the ethical quicksand she was approaching. That sounds like manipulation. It sounds like medicine, countered Rajesh. When someone has a bacterial infection, we don't just hand them antibiotics and hope they figure out how to use them. We study how bacteria behave, develop targeted interventions, monitor for side effects, adjust dosages. Why should misinformation be different? Alex pulled up a new screen, showing what looked like a clinical trial design. We're not manipulating people. We're studying the most effective ways to present accurate information so it can actually be heard. Like developing a delivery mechanism that gets medicine to where it needs to go, instead of being rejected by the immune system. The analogy was seductive, but Elena couldn't shake her unease. She thought about her neighbor, Mrs. Chen, again, how her eyes had changed when Elena mentioned her climate research. Was Mrs. Chen sick with misinformation? Or was she responding rationally to social cues in ways Elena didn't understand? What's our first experiment? She heard herself asking. Sarah exchanged glances with the rest of the team. Vaccine hesitancy in Millfield, Oregon. Population 15,000. Vaccination rate stuck at 60%. Strong community identity. Relatively isolated from major media markets. Perfect test case for localized intervention. What kind of intervention? Maya stepped forward, consulting a tablet. Instead of more facts and figures, we deploy what we're calling narrative inoculation. We identify the most trusted voices in the community, not doctors or scientists, but coaches, shop owners, longtime residents, and we help them develop ways to discuss vaccines that acknowledge people's concerns while slowly introducing scientific concepts. We're not changing what they believe, Lisa added. We're changing how they feel about what they believe, making scientific thinking feel like belonging instead of betrayal. Elena stared at the screens around her, data flowing, models updating, beliefs spreading and shifting like weather patterns across invisible landscapes of human connection. It was the most ambitious research project she'd ever encountered, and the most morally complicated. How do we know we're the good guys? She asked quietly. The warehouse fell silent, except for the hum of computers and the distant Oakland traffic. It was Sarah who finally answered. We don't. That's why we need to be scientific about it. Transparent methodology, peer review, replication studies, ethical oversight. We can't know for certain we're right, but we can commit to being wrong in more sophisticated ways. Elena nodded slowly, recognizing the familiar feeling of standing at the edge of unknown territory. It was the same feeling she'd had before her first independent research project, before her first major publication, before every significant leap in her career. The difference was that this leap felt like it might change not just her understanding of the world, but the world itself. When do we start? She asked. Sarah checked her phone. Field team leaves for Millfield at 8 a.m. You in? Elena looked around at the converted warehouse, at screens full of data about the most complex system she'd ever studied, the human mind at the moment of changing itself. Outside, Oakland was sleeping, unaware that in a converted warehouse, 7 scientists were preparing to conduct surgery on the information ecosystem itself. I'm in, she said, and felt something shift inside her. Not her beliefs about science, but her beliefs about what science could be.